Hello, a Rosie math teacher coming at you from my 5th period grade 7 math class, where we are working on lesson 7-4, area of composite figures on textbook 135, but you are doing your homework online, showing work evidence on textbook page 135. Composite figures. Guys, this is when they take other shapes we recognize, mash them up together to make something new and different. Kind of like item number 4. What two shapes did they mash up on item number 4? A square and a triangle. So they're just asking you to find the area for each piece and then what them together to find the total area of the composite figure. Add them. Excellent. Because when you want to find the total area, you would therefore need to add to find that total area. I already had my class write down the formulas they will need along the way. So even though I've erased it so you can see number 1, can you all look at it in your white space where you wrote it ahead of time? All right, so I want everyone to tell me, what shape should we be tracing with Miss Rose right now? What shape is this?
Square.
It is a square. Excellent. How did you recognize it was a square and not just any old rectangle? Because all the sides are the same. What's the big math word for that? All the sides are congruent. All sides congruent. Now remember, your formula for a square area is A equals, what did I have you write down?
B.
No. For square, S times S. You could do S squared, but we're going to stick with S times S. So please write that, class, underneath item number 1. A of that square equals S times S. Then I want you to write the symbol of what you're going to do with the area of the square, and then the area of the, guys, what is the shape on top? It is a trapezoid. Excellent. So please write yourself a plus symbol. I'll get, I'm sort of out of the way. That student might need to move if I'm just in the way. Okay, A equals S times S. And guys, let's go ahead and put that inside of parentheses, and then plus, and make a new set of parentheses, and let's write the formula for area of a trapezoid. Say it now, please. 1/2 times height, and then parentheses, base 1 plus base 2, little parentheses, and then a big one. All right, underneath each piece, let's first talk about what numbers will we use in place of S for the square. Say it, please. 12 times what? 12. Go ahead and write that with parentheses around it. I'm showing you how easy these composite figures are when you just plug everything into the calculator all in one moment. So you would start by doing 12 times 12, and that takes care of your what shape? Your square. All right, now type write your plus sign. And then underneath 1/2, what shall I write? 1/2. Underneath H, what shall I write for the height of the trapezoid? It gives it beside it. Great job catching that. So I will write a 6, so 1/2 times 6. And then in parentheses, I'm going to write a number for base 1. What is the upper shorter base?
6.
They gave you 6. So put that for base 1. If that is base 1, and y'all, this side of the square with all congruent sides is also the measurement of the base of the trapezoid. So what is that measurement?
12.
It is 12. Do you see where we got the 12? All right, and that would be the small parentheses and then the big parentheses. Yes. So in a moment, when I turn you loose on this, you are literally going to type everything that you see here. Beginning parentheses, 12 times 12. Area of the what? Square. Type the plus sign because we need to take area of the square plus area of the trapezoid. Yes? Okay. Then you would type beginning parentheses, 1/2 times 6, beginning parentheses again, 6 plus 12, ending parentheses, ending big parentheses, to include all the numbers that will give you the area of the what?
Square.
Trapezoid. We already have the area of the square. Once you type all of that in your online calculator, it will give you the total area of the, use the new words, composite figure. All right, I want you guys to go ahead and look at item number 2. Keep that work, you're not starting it yet. Everybody keep that work ready. And then I want you to go to item number 2. Everybody go to number 2. It looks like a green, now I'll be honest, this shape all on its own is actually, if you rotated your book 90 degrees, it's a trapezoid. One pair of parallel lines, the other pair not, but they don't give you the right measurements to use the area of a trapezoid formula. So we need to cut it into 2 other shapes. Raise your hand if you would like to say what shapes we're cutting it into. Go.
Square and a triangle.
Okay, I'm loving the word triangle. Let me go ahead and trace one triangle and then see if you can figure out the other shape. What is the other shape? Exactly. So guys, go ahead and trace your one triangle there and then trace your other triangle there. Do you agree it's actually 2 triangles that are different measurements? All right. So what do you think we need to write to remind us how to solve this one? A equals, and guys, I let you write 0.5 in place of 1/2. It's just easier to type in the calculator. Let's go ahead and start with 0.5 times what? Times base times height. And then keep all of that in parentheses for the first triangle. Then on top of that, we need a what sign to show what we're about to do with the 2 triangles? A plus sign. I heard it over there. Thank you. And then another parentheses for the other what? What's the other shape?
Triangle.
It's still a triangle. Good. So am I copying the same thing again?
Yes.
Yes. So again, I'm going to write 0.5 times base times height and ending parentheses. All right, everybody look. Underneath the 0.5, what do I want to copy in the calculator in a moment? That's right, 0.5. And let's say we're doing, let me trace this bigger triangle in red. Let's say we're doing that red triangle first. What would be considered its base? Now hold on a second. Let me remind you that right here, I'm going to trace that the way they had it traced. They are showing a line that always means what? Height. So if you need to rotate your book so you can figure out which piece is the base measurement, all right, but if you know the base measurement, raise your hand. Okay, tell me.
Is it 4?
It is not 4. We want to look at the red triangle for right now. Okay, so can you figure out what the base measurement is if I'm telling you this dotted line is the height? What is it?
It's 6.
It is 6. So class, make sure you are typing or writing times 6 for the base, and then times, raise your hand if you know the height, for the red triangle. Go. It is 5. Excellent. Guys, are you understanding where we're getting our numbers? So we have done 0.5. We have done the base of 6. We have done the height of 5. Are you with me so far? All right, continue. That is the measurement of the first triangle, the bigger one. Now I want you to look at the smaller one. It's 4 feet here, and it's 3 feet here. Now listen carefully. Do you notice that they are showing us that this is a right angle here? This is at a right angle. And remember, wherever a line runs perpendicular to the base of a triangle, that is therefore the same as the height. Are you following why that is considered the height of the bottom triangle? Okay, so underneath, first of all, what symbol shall I copy? Say it again. Plus, thank you. And then what is the first thing to copy after that? Parentheses 0.5, multiply that times a base of, raise your hand if you know the base. Go. 4. Guys, are you seeing where she got 4? And then times a height of, raise your hand if you know, go. Excellent. times the height of 3, ending parentheses. Do you realize in a moment, when you type this on your online calculator, it will give you the final total because you've already put the plus sign in the middle on the calculator. Aren't you loving how this is not that hard? Okay? I do know when we get to it in a moment, some children were struggling with item number 5, and tonight's homework is 1 through 5. So I'm going to troubleshoot with you a little bit to help you understand what these numbers are actually worth. Are we following along? We should already have a writing tool. Nobody's reaching for anything else. Okay, then just quickly get something else that writes. All right, number 5. What 2 shapes do you think I should turn this into? A rectangle is one of them. Guys, trace the rectangle part. And then, what is the other part? Triangle. Trace the triangle. All right, now look back at your formulas. What is the formula for area of a rectangle? Length times width. Love that quick answer. What will I add that to? The formula for the area of a triangle. What is the formula for area of a triangle? 0.5 times base times height. Are you following so far? And yes, we could just, oh good, she found another writing tool. All right, so now let's look at our rectangle. This part's not that bad. What do you think I need to multiply length times width? What will the length be? Say that, please.
20.
Okay, I'm hearing most of you say correctly. Say it again. 20. So put this in parentheses, 20. And am I doing times, divide, add, subtract? What am I doing right now? Times. And what is the width?
6.
It is 6. And then what sign will I copy? Plus. New parentheses. What amount will I copy? 0.5. Excellent. Love that participation. Times. Now hold on a second. They want a base that I'm going to trace in green. And let me remind people at home, I know it's harder to see on my screen if I don't trace it. So this number here says 8 meters for just this section. This number to the right of the triangle says 6 meters for just this section. And there's a reason why I'm reminding you that the line along the bottom is 20 meters total. So if I know that this entire line is 20, and I know that this little piece plus this piece plus this piece equal 20, raise your hand if you know what I can do to figure out my missing piece. Anybody? All right, I'll tell you the first step. Add the 8 plus the 6. What do you get? 14 is correct. So if this piece, think of these like 2 pieces of string. There's a piece of string here. There's a piece of string here. How long is this piece of string?
20.
20. How long is this section of the string? 8. How long is this section of the string? 6. So if I put the 8 and the 6 together, what section of the string is not the base of the triangle? 14, right? 14 total. What can I do with the number 20 and the amount of string used up, 14, to find the amount of string left over for this little base here? Good. What is 20 take away 14?
6.
It is 6. So how long is this base?
6.
6. Go ahead and label it so you'll remember that later. And then remember this. And we did that correctly. Yes, good. And then remember, you are also writing that as the base of your what? Triangle. So what am I writing? Times 6. And then times, now this piece is a little tricky as well. I'm trying to help you get there. So listen to the reasoning. Notice they've given you a height of the entire composite figure, and that height is 10 meters. Right? Okay? Now, did they mark it off, and tell you the height here of the triangle? No, not at all. But do you think they gave you enough clues that you could be an investigator and figure it out? Yes, they did. Does anybody see the clue I might be talking about? The 6. Excellent. So if this whole entire height is 10, and the height of the rectangular piece is 6, what can I do with the 10 and the 6 to find a leftover piece here?
Subtract.
Excellent. And what do I get when I do 10 minus 6?
4.
I get 4. So the height equals what?
4.
4 meters. Do you follow how you got that? And what will you write now after the multiplication? You will write 4. And you will put an ending parentheses over that. Do you follow what you would then put into your online calculator to find your total amount for the composite figure? Do I have any questions? How many of you feel like, oh, yes, I'm going to be very successful? All right. Everybody is. Everybody. I promise you, everybody is waving at me like, I got this. Good luck.